All right, you guys, I am going to help you today go through the reassessment review so that hopefully next week you can come in to one of the math teachers, geometry teachers, and retake the quadratics assessment. Please feel free to pause the video at any time if I'm going too fast or fast forward if I'm going too slow. Hopefully this will help you. If not, please come see your teachers so that you can get some help before you retake this reassessment. Okay, let's get started. So the first chart that we see here is of some parabolas, and it's asking us about the discriminant value and the nature of the roots. And it asks us to fill in the blank with either greater than, less than, or equal to. Okay, keep in mind that greater than is going to be a positive number, less than 0 is going to be a negative number, and equal to is obviously going to equal 0. So if we have a parabola in this first example, it does not cross the x-axis. Okay, so therefore that means the discriminant value would be a negative, which would be less than 0. Okay, so therefore if it does not cross this x-axis at all, then there are two imaginary roots. Okay, in the next example, the parabola touches the x-axis here. It doesn't cross it, but it does touch it, and it touches it one time. So therefore, the discriminant value is going to be equal to 0. Okay, and let's be reminded also that the discriminant is b squared minus 4ac. It's the part of the quadratic formula that is under the radical. So when you calculate this, b squared minus 4ac, you will get 0 for the discriminant value, which means it will only have one real root. Remember, it is a real root because it actually touches our x-axis, and on the x-axis, real roots on the x-axis, real numbers exist. Okay, and on our last parabola, we have that this equation, this function touches the x-axis two times. So we have two real roots. Okay, and that means our discriminant value is going to be positive. So it can be any number that is positive. And so therefore it will be greater than 0. All right, so this set of questions asks us to simply find the discriminant. Again, I will remind you that the formula is b squared minus 4ac. The quadratic formula will be given to you on the EOC and on the reassessment, but the discriminant value is not set apart from that equation. So you really need to know discriminant and that formula b squared minus 4ac go together. And then it says state the nature of the roots. So our choices are two real roots, one real root, or two imaginary roots. Okay, before we get started, you must get them equal to 0. Okay, so the first thing we're going to do is minus 4 to both sides. Okay, so 10x squared plus 7x minus 4. Notice these are not like terms, so I cannot add any of them together. Okay, and so now I'm going to do my calculations. B squared, so this is my a. Remember the coefficient of the first term, b, and then c is my constant. So b squared minus 4 times a times c. Okay? And so you're going to take your calculator. You are simply going to type that in. If you have it just like I have it with the parentheses, you should have no problem, and you will get negative 111. Okay? So you think, all right, is it positive, is it negative, or is it 0? And this number is negative, so therefore we will have two imaginary roots. And that is the nature of the roots. Okay, this right here is describing what kind of roots we will have. Nature of the roots. All right, so let's do another. Okay, again, we do not have it equal to 0, so we need to get it equal to 0 first. So I am going to, now really, there's not one right way to do this. You could take the negative 5x to the right, or you could take the right two terms and take them to the left. I'm going to try to keep it as simple as possible, so I'm going to take the 5x to the right. Okay, so now I have equal 0 on the left side, and then I'll bring everything down in standard form, which means x squared comes first, and then my x term, and then my constant. Okay, so I have my a, my b, and my c. So b squared minus 4 times a. Do not forget your signs. That is something that I noticed a lot of people did on their tests. Okay, so be very careful. Another misconception that some of us had on the test was that we forgot to get it equal to 0. Therefore, it caused us to mess up. Okay, so now we can simply type that into the calculator, or you can certainly do this, by in your head. So 5 squared is 25 minus, and then 4 times negative 2 times negative 1. 4 times negative 2 is negative 8. Negative 8 times negative 1 is positive 8. And then simply subtract those. So you will get 17. So there's my discriminant value. And so therefore, is it positive, negative, or 0? It is a positive number, so therefore we will have two real roots. Okay, that means it will cross the x-axis. This is just an example. We don't know exactly what it's going to look like, but it could touch the x-axis 2 times. Now this one over here, again, this is just I'm not saying this is what the graph looks like exactly, but we can have an idea that it would be something along the lines of it is not going to touch the x-axis at all because of the two imaginary roots. Okay, so we're going to solve each quadratic equation, and you guys, there are 3 methods to solving, okay, that we have learned. One of them is by factoring, okay? So you can factor by GCF, difference of squares, and trial and error. I abbreviate that TNE in my class, okay? That's one way you can solve quadratics. The second way, I'm kind of going to come down here because I don't have enough room. The second way you can solve is by extracting the square root. You can only do this when there is no linear term, okay? If there is a linear term, and the linear term is the x, okay? If there's no x, then you can do it, like in number 3. You can do this method because there is no x. But in number 4 and number 5, you may not do this method because there is an x term. In this case, 4 and 5, or 4, it's an m, but it's the same principle. All right, and then the third way that we've learned is by the quadratic formula. The quadratic formula will work every time. So if you are too confused about factoring or extracting, you really can use the quadratic formula. Now, factoring and extracting do not work every time, so you kind of have to choose wisely there. Okay, so I see on number 3, it does not have a linear term, so I'm going to go straight to this method of extracting the square root. So that means you get, well, let me start over. I'm not going to skip any steps. So I'm going to add 80 to both sides. Okay, so 2x squared equals 80, and then I want to isolate the x squared. So in order to isolate it or get it by itself, I'm going to divide by 2. So then x squared equals 40. Okay, and then the last step, because it's called extracting the square root, we are going to square root both sides. One thing that students typically forget is that when you place that square root on the paper, you must remember the plus or minus. And as we know, 40 is not a perfect square, so it's not going to come out as a nice, pretty whole number, but it certainly can break down. Okay? Depending on who your teacher is, there are different methods to do this, where you can take out the perfect square. The square root of 4 is 2, so it comes out, and then the 10 stays in. And then other teachers will go ahead and let you break this down more, where you find pairs. So a 2 will come out, and then 5 and 2 stay in, and 5 times 2 is 10. So there's your answer, 2 square root of 10. Please notice, when it says solve, you've got to have x equals as your answer every time, or m equals in the case of number 4. Okay, so on number 4, I am going to try really, really hard to factor. Okay, I'm going to see if factoring is possible, because if factoring is possible, then it's going to make my life much easier. Okay, So I'm going to see if there's any way I can possibly factor. I feel like that might be possible here. So I'm going to kind of list out the factors of 21. So that would be 1 and 21 and 7 and 3. And then the factors of 4 are 1 and 4 and 2 and 2. And so then I am simply going to start trying things to see if they work. Okay? My intuition is telling me that 1 and 21 is probably not going to work just because those are kind of, 21 is a larger number. So I'm going to start with 7m and 3m. And then, I'm kind of looking at if I were to put a 4 here, that would be 28 here. That would be pretty large. So I don't think that would work. So maybe I could put a 1 in that place. Let's see if that would work. That would be 7m, and this would be 12m. And one has to be positive and one has to be negative, so I just picked positive and negative. When I subtract those, that does not give me 8. So that doesn't work, so I'm going to try something else. Okay, I'm going to leave my 7m and my 3m where they were. Okay, so now I'm going to try 2 and 2. All right, so let's see what that'll give us. Negative 14m, and this will give me 6m. All right, so when I combine those, I get negative 8m. Okay, that is what I want. However, some of us on the test stopped here and just left the parentheses, like factored. But you guys, the directions say solve. So you need to set each parenthesis equal to 0 and then solve those, and then you are done. So don't stop at the factoring step. You have one more step to do. 7m equals negative 2, divide by 7. So m equals negative 2/7. You can leave it like that. And then on the other side, we're going to add 2 and then divide by 3. So m equals 2/3. All right, so here are my two solutions that satisfy that equation for number 4. Okay, I'll go back and make sure everybody's clear. This was the final answer on number 3. Okay, on number 5 now, um, I am going to maybe try to factor it first because it looks like it could be factorable. First thing is I need to get it equal to 0. So 5x squared minus 2x plus 3 equals 0. If it can factor, that's going to be super great. Um, so it's going to be 1 and 5 and 1 and 3. All right, and so if I put 3 here and 1 here, and I know both of them have to be negative because of the minus in the middle and the plus at the end, that'll give me negative 15 and negative 1x. That gives me negative 16x. That is not what I want. So let's try the other way. There's really only one other option where I put the 3 here now, and I put the 1 here. That'll get me negative 5x, and that'll get me negative 3x. That gives me negative 8x. That doesn't work either. Okay, so what this tells us is if we've tried to factor and it does not work, we have to use the quadratic formula. Okay, we can't extract because of the linear term there, so we have to do the quadratic formula. Okay, so the best method to do that is to do the discriminant first. So b squared minus 4ac, okay? And I'm going to get my discriminant, and that's going to tell me, kind of give me an idea of what kind of answer I should be expecting. All right, so that gives me negative 56, okay? All right, so then that tells me I'm going to have 2 imaginary roots, which also should indicate that I'm going to have an I in my answer, okay, because my discriminant is negative. All right, I'm running out of room. I'm going to have to give myself a little more room. Okay, so now I just do the rest of the quadratic formula. So here's my A, my B, and my C if we need to go back. So negative B is the first part of the formula. Because my problem's already negative, I'm going to turn it to a positive. Plus or minus the square root of negative 56 all over 2A, and our A is 5. Okay, so I've gotten it set up really nicely, but I need to break this guy down. Okay, so I'm going to break it down. And I know that 4 and 14 go into 56. That might take a little bit of practice in the calculator to be able to get that. All right. So the square root of 4 is 2. So 2 plus or minus, and the negative has to come out as an I. So a 2 is going to come out because the square root of 4 is 2. Okay. Then my I, and then 14 stays in the house, and 10 is on the denominator. All right, I think I've gotten everything pretty simplified, but the last thing that I need to do is make sure I tell my class the Mickey Mouse. Not everybody knows that way, but basically you have to, Mickey's ears and face have to be divisible by the same number, and they are all divisible by 2. Okay, so 2 divided by 2 is 1, plus or minus. You do not need the 1 here because the I is kind of holding that spot, and then 5. So there is my final answer. X equals 1 plus or minus I root 14 over 5. Notice that is 2 answers, 2 solutions. Because of our plus or minus, I'm keeping them together just because it looks nicer that way. And we did notice that from up here to imaginary root, so that should have, we should have known that we were going to have an I in the final answer. Okay, moving along. Pause if you need to take a break or to make sure that you're really understanding everything. Okay, so we're going to do our Harvard or our HERVed for graphing these functions. Okay, I do the same thing on every problem. All right, horizontal is when there is parentheses. So because there are no parentheses, we know there is no horizontal shift. Reflections come from negatives. So that negative right there, because it is in the very, very front of our equation, is an x-axis reflection. And then our -7 is our vertical dilation, our vertical shift that is down 7. The dilation comes from a number out front of our x squared, and there is none, so we're good there. Okay? So I have to go in this order. If I don't, it will not be correct. So horizontal, nothing. Reflection, so my graph was like this. So when I reflected it, it is now like that. Okay? And then I go down 7. So 1, 2, 3, 4, 5, 6, 7. So here is my final answer. So my vertex is at 0, -7. Based on what we've learned with parabolas this week, hopefully you could have looked at this equation and kind of known to pluck out the vertex. There is nothing with the x, so it's 0 and then -7. Okay, let's do the same thing over here. This one is a little more involved than part A. Okay, so we have horizontal shift in the parentheses. Remember, it is always opposite of what you think. So -2, we would really think left, but it's opposite, so it's going to go right 2. Our reflection is a negative that is inside the parentheses. When it's inside the parentheses with the x, it is a y-axis reflection. Our vertical shift is up 4, and then our dilation is a stretch. And remember, that is when the number a is bigger than 1. Okay, so because 4 is bigger than 1, it's a stretch, which means it gets skinnier. Okay, so let's do these. This might take a second. So we're going to go right 2. We're going to do a y-axis reflection. So my graph looked like this, but when I reflected over the y-axis, it's 2 to the right of the y, so now it's going to be 2 to the left, like that. Then I'm going to go up 4, 1, 2, 3, 4, here, and then I'm going to stretch. So I'm going to erase this, but I hope everybody followed that progression. I went right 2, I reflected over the y-axis, I moved up, and now because it's a stretch, I need to show that it is actually skinnier. So I have to give a point of reference. I have to give my dotted graph. And because it's a stretch, if I stretch you up, you're going to get skinnier. So it's skinnier like this. And some teachers will even tell you that because the number's 4, you go up 1, 2, 3, 4, and over 1. Up 1, 2, 3, 4, over 1. It's sort of like a slope. So you can even get the stretch that way. Okay, so now we're going to go through our characteristics. So the vertex is 0, -7 on this one. The domain is negative infinity to infinity, always. So I'm going to go ahead and put it over here as well. Remember, the signs are always going to be facing to the right. Less than is always how you want it. Okay? Range is always the low to the high, or for my class, I would always say bottom to top. Okay? So the very, very lowest that this graph is going to go is negative infinity, and the very highest it's going to go is -7. Notice I put the equal to because it is part of the graph. It is a closed circle. Okay, where is this graph increasing? Well, it is increasing on this side of the graph, and it is increasing from negative infinity all the way until this point right here at the vertex. Okay, so we are increasing from negative infinity. And remember, when you get to the vertex, you do not want the y, you want the x value, because it's always, for these increasing and decreasing, you always want to go left to right. Okay? So where do we leave off? At 0. No equal signs, remember, with equal to's with the increasing interval. All right, rate of increase. What most people remember is if it's upside down, the words do not match. So this is decreasing. So then this one would be increasing. Okay? And then the decreasing interval is now from this side this way. So we're going left to right. Here's my farthest left that it goes, which is 0, which it also picks up from where I just left off with the increasing interval. And then it goes to positive infinity because it's going to the right, not because it's going down. All right, we have no zeros because it does not cross the x-axis. Remember, another word for zeros are x-intercepts. All right, the graph will either have a maximum or a minimum. In this case, because it is upside down, it has a maximum, so it's the same as our vertex. And then we will have no minimum because it keeps going down forever. And then if you remember, axis of symmetry is where you draw the line right down the middle of the graph so that it would fold up and match. And so that is a vertical line. We've been talking about that this week some. And it is x equals, is always how you write it, and it goes through at 0. Okay, so you may want to pause it and try this one on your own. It's going to be a little different because it's right side up, like facing upward, but maybe give it a try and then pause, give it a try, and then play it once you are finished. Okay, so the vertex is, I didn't write it on the graph, is -2, 1, 2, 3, 4. Okay. Our range, the lowest bottom to top, the furthest bottom that this graph goes is 4, and the highest that this graph goes is infinity. Okay, remember, increasing and decreasing, you go left to right. So this graph on that side is now decreasing from negative infinity all the way to the vertex, and then it's increasing on the other here that way. So it's decreasing from, I always start this way going left to right. So negative infinity to -2, remember you want the x, and then increasing from -2 to infinity. Okay? All right. And then the rate of increase, the words match, increasing and decreasing. Our zeros, we have none still. It does not cross the x-axis whatsoever. Maximum is none this time. Minimum is -2, 4. And the axis of symmetry is always the x of the vertex. So x equals -2. All right, so this point, you've really got to make sure you follow the directions very closely, okay? So convert the following from vertex form to standard form. All right, I can look at this and tell you that this is vertex form because of the parentheses. I could pluck my vertex right out. My vertex would be -4, -3. However, that is not what it's asking. It's asking us to go from vertex to standard form. So this is where you do your 3 steps. You're going to FOIL, then you're going to distribute, then you add or subtract. Okay? So the first thing I'm going to do is I'm going to FOIL x plus 4 squared. Okay? So I get x squared plus 4x plus 4x plus 16 from doing my FOIL first, outer, inner, last. Okay, then I combine these two together. All right, step 1 is complete. FOIL. Step 2 is to distribute the -2 to all of this. And then step 3 is to subtract the 3. All right, so you are only distributing, sorry, I need to make a little room. You are only distributing the -2 to these 3 terms here. So -2x squared minus 16x minus 32, and then you bring your -3 down. So you only distribute the -2 to what's in parentheses, not to the -3 at the end. Okay, and then the last step is we can combine these two as like terms. So our final answer is, and don't forget your f of x equals. Okay? All right. And so now we are converting the following from standard to vertex. So we're going the opposite way. Remember, standard form is the ax squared plus bx plus c. Okay, it looks like basically a trinomial, always no parentheses. So there's a little trick. The formula will not be given to you, so it is something that you have to have memorized, okay? I also remember that it's from the quadratic formula. If we go back to where the quadratic formula is, here it is. You can also think that it's just the first and then the denominator of the fraction. Okay, that's also how you can remember what the formula is. Okay, so let's go back here and let's do the trick. Negative b over 2a. So negative b over 2, and our a is an imaginary 1 here. Okay, so that's going to be positive 6 over 2, which equals 3. I have gotten my x coordinate of the vertex. Okay, that is, if I find the vertex, I've basically done what I need to do. Okay, but then I need to find my y. So I find my y by plugging in 3. Okay, you can take your calculator or you can do it by hand. It does not matter, whatever you would prefer. Okay, when I do this, I get 9 minus 18 plus 9, which will give me 0. So that means my y is 0. Now, I have found my vertex, okay? This is my vertex, but it didn't just ask for the vertex, it asked for vertex form. So I'm going to take my vertex, and now that basically tells us everything, almost everything that we need to know to put it in vertex form. Okay, so there's a number that goes here, a number here, and a number here. So this is your h, this is your k, h and k. So we put it in here. There's always a minus in the problem there. So if it's a positive, it's going to be a negative when you plug it in, and then plus 0, and then the number that goes here is the a. So the a from the beginning was 1. Now we can clean this up to make it look the best. You do not really need you do not need the 1 here, you do not need the 0 here, so our final answer would just be x minus 3 squared. All right, let's do it again with another one. So negative b is going to turn our 12 positive over 2 times a, which is -2. 12 over -4 equals -3. Okay, I've got my x of my vertex. Now I need to find my y. Okay, so I'm going to plug it in by doing f of -3 . Okay, you can literally type it just in the calculator just like you see it, with no problems, as long as you put the parentheses here and the squared outside of the parentheses. Okay, and when you make those calculations, you should come up with 1. Okay, so then I have my vertex, and now I can put it in vertex form. So a x minus squared plus k. So a, h, k. Here's my h, here's my k, so I'm going to go plug those in and that in, and my a is from up here at the beginning of the problem, which is negative 2. And the only thing I really need to do to clean it up is a negative and a negative together makes a positive. So we are done. All right, on the next page, now it asks for simply the vertex. So that last step that we just got through doing in 7 and 8 really is unnecessary at this point because we just want the vertex. Well, this is in vertex form, so you should be able to pick the vertex out as it is. This and this, H and K, you are done. So the vertex HK equals, now remember there's a minus in the formula, so it's a positive 7 and a negative 1/2. You're done. Not so easy here on this one because you have to remember the trick. Because this is in standard form, you see your A, your B, and your C. So you need to remember the little trick, negative B over 2A. So when I make my negative negative, it becomes positive. All right, so there's my x coordinate of my vertex. And so now I plug in my 2 to get my y. Okay, again, that can be simply a calculator manipulation that you just type it in, or you can do it by hand if you would prefer. So 2 times 2 squared is 4, 4 times 2 is 8, minus 16 minus 7. So then when I would do that, I would get negative 8 minus 7 is negative 15. So I am done. All right, the next set of problems, we are asked to find the solutions, okay? These can be the easiest problems if we understand what the question is asking. If we don't understand that solutions mean x-intercepts, then it's not easy. But if we just remember that solutions is another word for x-intercepts, then you can do this question really easily and quickly. So I just circle where they cross the x-axis. So x equals negative 1 and x equals positive 1. You're done. And so the next question says, does it have a minimum or a maximum? Well, because it is upside down, this point right here, which is also our vertex, is the maximum. And that ordered pair is, we don't go any left or right, so 0, and we go up 2. Please make sure you understand the directions, because if you understand the directions, look how easy that can be. Okay, so this is an EOC type question. It is a multiple choice question, and the best way to do this is to sketch a little graph, okay? So it gives us some basic information of negative 4, 7, okay? And it has a range of negative infinity to negative 7. This is a sneaky way of me telling you that the graph is upside down because negative infinity and then it stops at 7. Okay, so I know it's like this. I can immediately eliminate A, choice A, because it is a positive A, and we know that it needs to be negative. So one way to do this problem is you could put it in vertex form. Okay, and we know our vertex would be negative 4 and 7, our H and our K. So we could clean it up. Oh, I forgot to put my A. We also know that it's negative. Now, we don't really know if there's a stretch or a shrink. So we would have to kind of go back and look at our answer choices, B and C, to see if there's a number out front. And there isn't one. So I'm just going to leave negative, and then x plus 4 squared plus 7. Okay, you could absolutely work this out if you wanted to by doing your 3 steps, your FOIL, and then your distributing, and then your adding or subtracting. But I think it might be wiser just to take your x value and plug them in here and here, here, and here, and see which one gives you 7. So plug in 4, negative 4, excuse me, in both places. Now, please be aware that the negative in this problem has to go outside of the parentheses, okay? Because it is not in the parentheses in the equation. And so then you would just type them in and see which one produces the answer of 7. And the one that would do that is B. So we know that's the answer. So you have 2 ways to do this. You can put it in vertex form and then convert it to standard form if you want. That's one way. Or you can simply take your x and plug in to all the equations and see which one gives you 7. Okay, I know this problem has always kind of given us a little bit of trouble, but really if you read carefully, that helps you the most. So the first thing we want to do is figure out what x and h stand for. Okay, so we know that x is seconds, all right, and it says the height of the ball at any time. So we know that h is height. Okay, it says after the ball is kicked, determine how long it will take before it hits the ground. This is a sneaky way of us asking you how much time is it going to take if the height equals 0. So you're going to plug in 0 for h of t, and now we're going to solve. Okay, we do not want to be working with these larger numbers, so we're going to try to take out a GCF of negative 16. Let's see if that works. If it doesn't, maybe we should take out negative 8. But let's try to take out negative 16. Okay, so, and I want to take out the negative so that my leading coefficient here will be positive. Okay, so if I take out negative 16, that will leave me with x squared. And if I take out negative 16, oh, you know what? Look, I just made a mistake. I need to go back because both of these terms have an x, and I wrote it here, but I didn't put it initially. So we need to take out not only a GCF numerically, but with a variable as well. So negative 16x. So we will be left with x, and then 96 divided by negative 16 gives us negative 6. I just had a little brain lapse there, because a positive divided by a negative is a negative, and the x's will cancel there. All right, so now you know, please do not leave it like this. Now you have to set each piece, is kind of what I call it, equal to 0. So negative 16, x equals 0, and x minus 6 equals 0. So then divide by negative 16, x equals 0, and then add your 6, x equals 6. Now, we should think about which of these makes sense. Maybe both of them do, maybe one, maybe neither. So it says after the ball is kicked. So after the ball is kicked, so 0 seconds does not make sense, because that would be when the ball is resting before it has been kicked. Determine how long it will take before it hits the ground. So 6 seconds, we can have positive seconds. That makes sense. So 6 seconds is our answer. Don't forget the unit. Okay? You could even plug 6 back in here to make sure it really does equal 0. I like to know that I'm right before I turn in my test. So I would do that. And it does give me 0 when I plug it in, so I know I'm correct. Okay, and to the last two, depending on who your teachers are, you may shade a little differently. But these two problems are almost different than all the others because of the inequalities. So whenever you see this word, you need to be thinking shade. Okay? Shade, shade, shade. And if the graph is given to you, that is much easier. You don't have to worry about graphing. All you have to worry about is shading. If you see greater than, which that is that symbol, you are shading above the x-axis. Now, this is how I shade. Other teachers may shade this way on the x-axis, but either way, it means the same thing. Okay? All right, so You just have to say, where is this being shaded? Well, you are having two separate answers because they are disconnected. This space here is not shaded, so they are not connected. We are going to have two answers. So remember, you want to go left to right for both of these problems. Okay, so the farthest left that this part is going to go, well, it's going to keep going. So negative infinity, and then it stops here at this number, which is, I think, -3. I just kind of went over it. Yes, -3. And then it starts back up. I'm going to follow, follow, follow. It starts back up here. Okay, I don't want you to get confused. That's not shaded. I'm just showing you I'm following the graph. And it starts back up here, which is at +3. And then this graph is going to keep going to the right forever to infinity. Okay? Notice I do not have any equal to's because my original problem did not have an equal to sign. And so then once you have this done, interval notation is a breeze. If you have just the less than signs with no equal to's, then it's just going to be parentheses with the same numbers. And you're done. Okay? All right, and then the last one. It is also a greater than symbol, so I am going to shade above. Now notice it does have an equal to this time. So when I get to these numbers, I need to make sure I'm going to kind of color them in so I don't forget that they need to be closed circles. Greater than, so I'm going to shade above, is this tiny little piece here. So from left to right, what is the interval? Well, it starts at 1 and it ends at 3. So here's my interval. But I do need equal to's because they are closed circles. And then interval notation, if you have an equal to, you put brackets. Okay, so this sign dictates that side of the interval notation, and this one dictates that side. So then you just put your 1 and your 3. I hope you found that this is helpful for you. If there is something that you are still unsure about, please come see one of the geometry teachers, either your teacher or another one. We want to get you help so that you can improve your grade from this test and that you can be successful for the rest of this semester. Thank you.